You are listening to Science Coast with Mallory Havens and
Chris White.
And today our guest is
Piotr Szczurek.
Piotr, could you tell us a little bit about your role here at Lewis University?
Sure. So thank you for having me here. So I've been a professor here at Lewis for over 10 years. Well, it's like going on 12 years actually now. And from the very beginning, I was teaching artificial intelligence and other computer science courses. And then I got involved in creating the data science program and then became the director of the data science program. And I'm still in that role right now.
And also for the listeners, you're going to hear me call him Peter for many times in the podcast, so don't get confused. We're still talking to the same guy.
Yeah, and that is my name also, yes.
So artificial intelligence really broke into the scene in the past year with ChatGPT. But I don't know if there's a widely understood, if it's widely understood what artificial intelligence actually is. So can you start by telling people what artificial intelligence is?
That's actually a tough question because I think you will ask 10 people and you'll get 10 different responses. There's certain characteristics that I think are common and we would like to see in whatever we call AI. And by the way, there is AI as kind of an entity, and then there's the AI as the field of study, whose goal is to create those entities. But those entities are, definitely some kinds of systems that we won't want to be autonomous and explore their environment, learn from it, and solve some kind of problem, get to some kind of objective. And that's the general definition. But not everything really fits into that definition. And the definition itself is kind of broad and not always what people expect. Not always what people call AI. So there's been other ways of defining or trying to test if something should be considered AI or not. Most famously, the Turing test, which is about trying to see if we can fool a human into thinking that they're talking to a machine instead of that they're talking to a human being instead of a machine. And there's been attempts at trying to pass that, but once we do pass it, and I guess there's been some systems that could, even before ChatGPT, it's not quite clear that we have created AI yet. So
I think mimicking human conversation is not the same as intelligence, because all you're doing is mimicking.
Yeah, so then you have to ask yourself, what is intelligence in the first place? And it's tough. And there's something called the AI effect that basically means that whenever we create something that we as AI researchers would think like, well, okay, this is AI, this is really the next leap forward, then people get used to it or people see how it works and they're like, well, this is not intelligence. This is just, you're just a giant lookup table and you're just trying to basically answer a question with just looking things up in a database. And that's not people's understanding of AI.
I thought AI had something to do with machine learning and that the device or the program created can train and educate itself on something that it wasn't pre-programmed to do. So it came up with new things.
Yeah, that's kind of how people currently envision AI, but that's not really what AI was about. Certainly not back when it started, because AI has been a subset of computer science that people have been researching for many decades. And in the beginning, a lot of it was rule-based, and people just pre-encode some rules and use those to then implement the system. And most famously, ELIZA created in the 60s was like that. It was a system chatbot that would hold a conversation with you, but basically it would just kind of answer your questions in the form of answer your whatever you type in. It would just turn into a question like a psychiatrist would or something. Psychologist.
Well, it's almost deterministic. I mean, I think the early programs were deterministic, I think is what you were saying.
Yeah, but even if you include the elements of randomness, I mean, it could still be rule-based, and those could be hard-coded. It could be something you design, and certainly we would want to see elements of learning in it, but it's not really required. But yeah, it's something we definitely these days use a lot.
So training, I think my understanding is a lot of the tools that are out there right now were trained before they were released for general use, and they were trained on publicly available data, whether that's printed data, whether that's sound data, whether that's images. And some people would argue, I think there's a lot of artists out there that are complaining because a lot of these artificial intelligence tools were trained using copyrighted materials, and now the chat GPT might be creating something which some people would say is original, but it was influenced heavily by all of these, by what it was trained on. And I'm just wondering what your opinion about that topic is.
Yeah, so this is kind of gets to the heart of the matter of how machine learning got so integrated into AI. It wasn't like that before. So first, when we were trying to figure out how do we make a machine recognize a face, we would try to think of some kind of an algorithm that would use some logic to try to say, well, a face has ears, eyes, nose, all these things, and we can look for it, and we can try to devise like what are the different parameters in which you could potentially have a face in a picture. And then people realized that's hard to do, and we weren't really getting good results from doing that. There has been a number of approaches. So later on, once people realized like, well, maybe we can just give it a bunch of images of faces, tell it that's a face, and that's where the machine learning part comes in. And you use algorithms that just turn those into models that can predict whether it's seeing a face or not. That would work better, and it does. And it didn't really took off. I mean, that's been around for so many decades, but we really had to wait until advances in hardware and algorithms as well that turned that into something we see today. But so that's the approach by which AI is being implemented now. We just feed it a bunch of examples and say, hey, just do this. And it works well. But yeah, it does require data, and that has to come from somewhere. And a lot of that comes from the data we generate as humans. So, that's what allows us to solve the problems, but then we have to give up something for it. And that something is, our creations, and you gotta have that come from somewhere. It's not going to be free.
And yet, to prove I'm not a robot, I have to select all the pictures with stoplights in them, and somehow computers can't do that.
Not yet.
They actually, so there is this idea of an AI complete problem. That's something that's kind of as hard of a problem as you can imagine in AI. And vision problems, like those kinds of things, detecting stop signs or other things in images, used to be one of those. And these days, I'm pretty sure we could solve that problem these days, and a lot of others.
One of the things people don't realize is that artificial intelligence has been around, and Piotr, you said this already, decades. This is not something which just came about over the past couple of years. When I first started finishing my graduate program, and I'll date myself, I got my PhD in 1990. So
I was 5.
Yes, thank you. In the very early 90s, physicists were using things like neural networks. And in elementary particle physics, we have these very complex data sets, and it's always like, we're saying we're looking for the needle that's in a haystack. Well, finding a needle in a haystack is really hard. And so we were trying to figure out how to use neural networks to have the computers actually find the needles for us. But we had to train the computers as to what to look for. And so we would do as detailed simulations, computer simulations of our experiment as we possibly could make them as detailed and precise as possible. And then create these, these events, as we would call them, for the computer, and say, these are what the data that we're interested in look like. Can you go from our data set, find them for us? And I'm just curious, and we call those neural networks. I'm curious, Piotr, what you think of is that artificial intelligence?
I guess you could say that's some form of intelligence. I mean, intelligence really is about processing things in order to solve a problem, right? So the better you are at it, the more intelligent you are. I don't think it's necessarily like a binary thing where you are either intelligent or you are not. There's a spectrum, and use of artificial neural networks has definitely allowed us to solve bigger and bigger problems, like the problems in physics you mentioned, and problems in image recognition, many others. So it is definitely a part of intelligence.
In bioinformatics, like we wouldn't be able to analyze genome or genetic sequences or the proteome or anything without computer aid.
Yeah.
I've heard that that some of these tools are getting better at diagnosing our early stage cancers from medical images than radiologists. And there's just certain patterns that the computer is better at identifying. So if you can feed these tools good data, then they end up being better at pattern recognition than humans are. And when the pattern that you're looking for is subtle and complex and multivariate.
Yeah. I think it's maybe a common misconception is that AI is going to have consciousness. Because I think that's
gosh.
I think
What if we got Peter and somebody else together to talk about that, like a psychologist who's an expert in consciousness?
Yeah, because I think people are afraid of AI and the concept of like the Matrix or something where it's going to enslave humanity. But wouldn't that require some sort of forethought or I don't know. What do you think?
Yeah, I think consciousness is overrated. It's one of those nebulous things that it's impossible to define. Once we find some test to say that, hey, this is consciousness, then if we do mimic that, then they're like, no, and then we find some other test, and it's like keeps changing. So we definitely, as humanity, want to make ourselves special. We always try to think of things that makes us special, like, oh, we could use tools, but then we found out, oh, animals could use tools. Or we could recognize ourselves in the mirror. Well, there's animals that could do the same thing. So,
and now computers that can do that.
And computers can probably do that, yeah. So it's whatever you come up with, and that's why, this consciousness idea, I think it's just for us to keep ourselves thinking we're special somehow. I don't know if it's actually a true thing, but having forethought is something machines are actually capable of. I mean, we do implement AI with planning capabilities. So they are actually thinking about what's going to happen in the future, and they discount, future events to kind of help make sure that it does better now. But it is actually possible for the machine to think ahead. That's what makes it smart.
I just think that, if you give authority and independence to these computer-operated systems and allow them to decide for themselves what will happen, so that if they have agency for themselves and if they have the ability to make a decision without a human intervening, that's, I think, when it begins to get dangerous. So, for example, you have right now military drones that are flying around, and they have sometimes American pilots, from Kansas, piloting them and making a decision as to whether the bomb should be dropped. But at some point, they're going to let the drone itself decide whether it will drop a bomb. And then at some point, the drone will decide where to drop that bomb, when to drop that bomb, who to drop it on. And that's when I think people get worried that, well, the humans are no longer, we've released this decision-making process and relinquished this decision-making process to a to a computer. And what if that computer starts making decisions we don't agree with?
Or it gets hacked.
Then what?
Yeah, that could be very bad. The idea of a drone bombing on its own is terrifying.
But that could happen with even a dumb device, right? Or a human being, even more so sometimes than a machine that's built around certain parameters and it's meant to be safety critical. A lot of it is just, how do the humans actually program it? How do they train it, the models and things like that? So whatever you develop, it could turn into good or bad, but that's with everything you build. You build, a crane to build a building, but it could topple over and kill a bunch of people. Anything you build, it has that capability. So I don't think it's unique to AI.
What do you think about computer code that intentionally miscopies itself and can gain function from that? So I'm specifically thinking about there's computer code that's used to study evolution where it can just make errors in copying and then it can learn logic gates or gain logic gates. And do you think...
Or build new machines?
Well, not this particular system, but do you think it's possible eventually for computer code to be allowed to copy itself with error and gain functionality that we hadn't pre-programmed in?
That's really what machine learning is, really, in theory, that it is trying to find something, to optimize itself, change itself to make itself better at accomplishing some goal. So that's artificial neural networks. That's how they work. We represent the model by these weights on these connections between those artificial neurons, and the system changes those weights to adapt and to make sure it performs better. So that's actually what we have now. We also have this thing called evolutionary algorithms or genetic algorithms that are kind of more like the Darwinian kind of evolution. That's been applied to neural networks as well, where you can not just change the weights, but change the whole structure. It's just like kind of changing your brain around so that it gains some functions, and potentially we could do that right now.
It's a very fast-moving field.
Yeah, and pretty soon we all get to just be like in WALL-E, where we just sit on like floating beds and the computers do everything for us, right?
Promise?
I hope so.
Okay.
All right. With that, the views, thoughts, and opinions are expressed are the speaker's own and do not represent the views, thoughts, and opinions of Lewis University. The material and information presented here is for general information purposes only. The Lewis University name and all forms and abbreviations are the property of its owner, and its use does not imply endorsement of or opposition to any specific organization, product, or service. This podcast was produced in the WLRA podcast studios at Lewis University. Visit lewisu.edu for more information about Lewis University. This has been Science Coast with Mallory Havens and
Chris White
and
Piotr Szczurek.
bye.